So this lesson is going to be looking at how to calculate percent yield. So percent yield is actually pretty simple. The hardest part is to figure out the theoretical yield, which is what we were doing in the previous lesson. Okay, so in the previous lesson, we were finding the theoretical yield using the ratios, finding the limiting reactant in order to do that. Okay, so we're going to be kind of covering again how to do limiting factors or limiting reactants in the equation, using the equation. And then using that number that we find, we can easily find the percent yield. Okay, so for this example, we have a reaction of 6.21 grams of copper and 7.22 grams of silver. Okay, and it's going to produce this much of silver, the 0.16 grams. So what is the percent yield? So the first thing that we need to do is figure out which is the limiting reactant, okay? So we have a certain amount of copper, we have a certain amount of silver nitrate. We have to see which one is going to produce the least amount of silver, okay? So first, we need to be able to convert from grams that they gave it to us into moles and then convert it between using the ratios to convert to moles of our silver and then convert that to grams, okay? So first we need to know the molar mass of each of the compounds involved, okay? For limiting reactant, you have to find the molar mass of all the reactants. So in this case, we have 2, okay? These 2 are our reactants, and then 1 of our product, okay? The specific product that this question is asking or referring to is silver, so we're gonna find the molar mass of silver. Okay, so for copper, there's no subscript, so there's only 1. So we're just going to take 1 times the mass that we have on the periodic table. So that would be 63.546. Okay, for the mass of our silver nitrate, we have 1 atom of silver, because there's a subscript of 1. Okay, so 1 times the mass of silver, which is 107.87, plus 1 times the mass of nitrogen, so 1 times 14.007, plus 3 times, because there's 3 oxygen atoms in this compound, 3 times the mass of oxygen on the periodic table, which is 15.999. Okay, I would add those all together to find the molar mass of AgNO3. Right? And then for the molar mass of silver, there's just a singular silver atom. So 1 times 107.87, it'll just be the 107.87. Okay? Now, whenever I go to set this up, I'm going to find out how many grams, 6.21 grams of copper will produce of silver, and then I'm going to figure out how much 7.22 grams of silver nitrate is going to produce of silver. Okay, so for the first one, I'm going to start with copper. So I have 6.21 grams of copper. I have to convert that to moles. So I'm going to use the molar mass. So that would be the number that we got here. So 1 times the copper, which was 63.546, so that would be the number I put here, is equal to 1 mole of copper. Okay. So I have moles of copper here. I'm going to drop it down to here. Okay, whatever we have up top has to be dropped below. Okay, so I'm going to look at the ratio between copper and silver in order to convert from copper moles to silver moles. Okay, so copper, there's a coefficient of 1 out here. So I would put a 1 mole of copper. And then if I look at silver, there are 2 moles, right? The coefficient is 2. So there's 2 moles for every 1 copper, or every 1 copper is going to produce 2 moles of silver. So I have a 1 and then a 2 here. Okay. I am now in moles of silver. I'm going to drop moles down because whatever I have up here has to be dropped down here. And then I'm going to use the molar mass that I calculated of silver. So it would have been just the mass of 1 silver atom, which was 107.87, is going to go here, equals 1 mole of gold. Okay. Then I'm just going to multiply across, and divide in order to find the answer. I believe the answer is like 21, somewhere around there. Okay. For the next one, I'm going to now focus just on silver nitrate and how much 7.22 grams of silver nitrate can produce of silver. Okay, so I'm starting with my 7.22 grams. I would need to know the molar mass, which we calculated here by multiplying and then adding up the 3 to find the molar mass. Okay, again, I need my ratio. My moles of silver nitrate, I have 2 silver nitrates to 2 silvers, okay? So my ratio will be 2 and 2, okay, which will reduce to 1 over 1 if you want to just reduce there, okay? But if you want to just go straight off of the equation that is balanced, it would be 2 and 2, okay? And then I would need to know the molar mass of silver, which again is the 107.87. I would put that here. I'd multiply across, and then divide. And I believe it's around 5 is our answer there. Okay, so here, this one produced 21 grams of silver. This one produced 5 grams of silver. I don't remember what the exact values are, but this one produces less. Okay, this one can only produce 5 grams of silver. So this would be my limiting reactant because it can only make less or the least amount of silver of the two. Okay, so that value that I found is the theoretical yield of this mixture. And so I would take that value that I find here and I would plug it in here. I would take 0.16 divided by that value times 100, and it's like 3%, I think. Like 3.5% is the answer that you get for that. Okay, on your homework, whenever you're going to do these problems, whenever I have you balance the equation, make sure that whenever you go to set up your ratios that you're using the coefficients that you selected to balance that equation. Okay, don't just put 1 and 1 because you're looking at the unbalanced equation. Make sure you're looking at the coefficients that you selected for that equation to be balanced in order to set up your ratios.